So in this video, I'll be going over the code I created for the VEX EXP to complete the autonomous portion of the competition, as you see here in front of you. So first things first, what you want to do is name your program. So what I've done is named it EXP Auto and saved it. And the second important thing that you need to do is choose what slot you want to download your program in. This is important because let's say if you have multiple autonomous programs, you don't want it to save into the same slot because then it will erase your previous program that was downloading into your robot. So having multiple slots is good in order to save all those different programs you got. Once you have done that, then you'd want to go into the top right of your screen and click this button that looks like a motor. And what this would do is it will give you the option to add a device. And here you can add all your buttons, all your motors, sensors, and anything else you have connected to your robot that you want to use for your autonomous period. So the way that works, you just click on add a device and click on, let's say you want to add a motor, you click on motor and you select the ports that your motor is connected to. So let's say I had an extra motor, I wanted to connect it to 9, I just click 9. I would name the motor, I'll just put motor 9. And I can also switch the polarity of the motor, so whichever way you'd want it to be, the forward and reverse side. Then you click done and there's a new motor. Same way for any sensor you have. If you wanted to add a new sensor for, like, let's say vision, then you just select your port again. You name it just distance or vision. Say distance 1. Press done and there you go. So once you have added all your devices, so all your motors and sensors to your robot with its corresponding ports, then what you can do is begin programming. So in my code, in each section I've commented what it does. So this section is my setup. This is where I have all my variables, the motors, like what it's supposed to do at what speed, and is it supposed to just brake or hold whenever it stops. Over here I have my main code, so this is what actually runs the entire program. And then I have this other section, it's called a my block. This is part of the main code, but it just keeps it simpler on the side. And then over here towards the right, I have color detection and driving, which this will be used for the end of the program when the robot is looking for the color tape. So first things first, the setup is the most important when it comes to telling your robot what you want the motors to do, or in motor terms, what you want the motors to be doing whenever the robot begins. So first things first, I have a variable. I just set that count to 0. This will be used later in the program, mainly towards the end. Then I have my arm motor. So if I were to go here, I can tell you that my arm motor is in port 4. This is just a motor that's going to be used to rotate the arm up and down to score. I have it set to position 0 degrees whenever the robot starts immediately. Its velocity to 50%, its max torque to 100%, so in case the claw is too heavy or anything, it would still be able to lift it with no problem. And it's stopping to hold, so after the robot stops and lets go of that arm, then it will keep it in a position, in a holding position, so it will not drop back to the floor. And also I have it to spin to 45 degrees right as the code starts, that way it's not touching the floor. The next part I have is setting the drive velocity to 25%. This is how fast the robot will be moving forward and back. The turn velocity to 10%, so in case I want the robot to turn, it will be moving at 10% of its speed. Its heading and rotation will be 0 degrees. That means that it's facing directly straight. And I have the claw of the robot set to 70% speed. After that is just setting our optical sensor to color mode and with the light power to 100%. And also the last step in the setup is setting the distance sensor I have on the robot to equal the distance it measures between the robot and the wall. And I will show you how that plays an important part later on in the code. So now I'll get started with the main code. In the main code, the first thing I have the robot do is spin the claw forward. So what this does is it spins the motor claw, the motor on the claw, in the forward direction, which grips onto the disc. Then it will wait 0.3 seconds, and then it'll continue with this score my block. And what the score my block is my own block I've created that has certain movements already made on the side. And the purpose of this is to decrease the complexity of my code so it's a lot easier to read. Because if you see down below, I have several of these pink blocks. And if I were to get rid of them and add this code, then it will just make my code a lot longer and more congested. So that's why I have these my blocks, and the way you create them, you just go to my blocks, you will make a block, and then you can put whatever you want in it. Or if you wanted to do what I did, just name it and then press OK. And you have your own my block. So in this my block, I have the movements created for the scoring of the robot, or movements from lifting up the arm, placing it, and going back to its original position. So for example, the arm will move to position 910 degrees. What this will do is rotate the arm backwards 910 degrees and just stop from there once it has reached 910 degrees. Then I will stop the claw. And the reason I have to stop the claw is because over here, if you realize, I told it to spin the claw forward, but I never told it to stop. And the reason for this is because I don't want the robot to lose grip on the disc when I move his arm up, because if you have it to spin claw and I have to stop claw right under it after 0.3 seconds, then it will not have any firm grip on the disc, and when it makes the movement to go to position 910 degrees, then there's a good chance it might just slip out and not score. That's why I have it to spin forward over here, do the movement, and then stop the claw, so it always has a firm grip on that disc. Then I put it to wait 0.2 seconds and spin the claw reverse. That way it opens the claw and scores the disc. Then I have another wait a third of a second and stop the claw from spinning outwards because we don't need it to spin anymore once it is open. And then wait another 0.2 seconds and spin the arm back to position 45 degrees, which was the original position it was in, as you see over here. And the reason I don't have it to 0 degrees is because if the arm goes back to 0 degrees and the claw might drag on the floor, and while the robot is conducting its autonomous, then it's going to mess up the whole autonomous due to it dragging the floor, creating friction, making it turn the wrong way, or it just in general not moving at all because of how much friction it's creating. So once this last command is connected, then it will go back to the main code, go back to its original little block, and then continue everything else after that. So the following portion is this repeat until loop. And what this loop does is that it repeats whatever's inside it forever until this condition on the outside has been met. So for example, in this scenario, this loop will repeat driving forward forever until the distance sensor object detects that it is greater than 20 inches away from the wall. Once it is greater than 20 inches away from the wall, it will exit the loop and stop driving. And also what you've noticed here is I have this turn to heading 0 degrees and turn to rotation 0 degrees. And what I've noticed, this helps a lot in accuracy for the robot. So whenever you're driving forward and the robot starts to turn like a little bit to the left or a little bit to the right, or it gets stuck on the carpet and it just makes the whole thing move around and face the wrong way, this turn to heading 0 degrees and rotation 0 degrees makes it so that it realigns itself perfectly straight all the time. So I really highly recommend this to include in your code in order if you're going to be doing anything that's driving forward or driving backward and you want it to be perfectly straight. It also works for any degree, so you can have 90 degrees both, and it'll make the robot always face 90 degrees, so it's a right angle towards it. After that, then exit loop, and you wait 0.2 seconds. And I forgot to mention earlier, the reason you have all these little waits of 0.2 seconds or 0.3 seconds is to create little delays. And the reason for this is so that the reason for this is so that the code doesn't make all the buildings run at the exact same time, one after the other, because then that would mess up the whole autonomous, since it'll be jolting and maybe it'll shift a little bit to the left or right, and then it will just miss every time it scores a block. I mean, it's a disk. Um, so there are just little delays there to slow down the code, so it's not moving on instantaneously. The next part I have is spin the clock forward, and this would make the clock close on the disk and just grab it in general. So once it has grabbed the disk, it will wait 0.3 seconds and do this other loop that is driving reverse. So the condition in this repeat until loop is that the distance has to be less than the distance variable or equal to the distance variable. And what that distance variable is right here. So set distance to the distance between the wall and the sensor when it first starts in the autonomous period. So this is when the setup is, and the code reads the distance, sensor reads how far it is from the wall immediately. And that's, let's say it's 10 inches, and it will always be 10 inches, the distance variable. So if it's 10 inches, then over here it has to be 10 inches or less, or equal to 10 inches in order to get out of this loop. So drive backwards, turn to heading 0 degrees or rotation 0 degrees to make sure it's always straight. And then once this condition has been met, then it will stop driving. Once it stops driving, it will wait 0.2 seconds and score again. And as I mentioned above, it will do all these set of movements in order to score the disk. And I will continue on doing that for the rest of the code until it has reached over here, and it will broadcast a color sense. The only difference between each section of code is just the distance the robot is going forward based on the distance that I've set here to the distance sensor to detect from the wall. So the first one was originally 20 inches from the wall. If the robot is 20 inches or more from the wall, then it will stop driving to grab that first disk. The next disk will be 27 inches or more from the wall. It will grab the second disk. And the last one is 35 inches or more from the wall in order to grab the third disk. Once it has completed all these three loops. Then I will broadcast this color sense message. And once it has broadcasted the message, then I will move over here and until where I'll move over here and the two blocks to say when I receive color sense, the message color sense, then I'll run these two programs. So I'll just go over the first one. The first one is a forever loop with 3 if statements inside of it. Each if statement is a different color the robot has to detect. So the first one, it's blue, next one will be green, and the next one will be red. Over here, I don't have the hues in for blue, for green or red, because it's just for you guys to figure out, because it won't be the same for everyone. I do have blue though when I was testing it, but it might be different for your robot since the sensors could vary depending on light, carpet, or just your sensor in general. So what this does is forever if the color is in between 270 and 257, if it's in between these two, then it will change count by 1. And originally count was set to 0. So changing it by 1 would just be adding 1 to it every time it detects a color. And so you have blue, red, green. And over here is the driving. So whenever it receives a message, color sense, it will set the drive velocity to 10%, slower than it originally was, which was 25%. Turn the heading to 90 degrees and the rotation to 90 degrees to make sure it's facing towards the right, like in a right angle. Then it will enter this repeat until loop, which the condition is count is equal to 1 or greater than 1. If the variable count is greater than 1 or equal to 1, then it will exit the loop. And in the loop, I have it to drive forward, so turn right, drive forward, facing 90 degrees, and once it detects a color, red, blue, or green, then it will exit the loop because it will make count 1 or more. It'll stop driving and play a sound, and right now I just have it to power down the sound, which does not matter what sound you have as long as it has a sound. And that's about it.